we can write a fraction with pretty much any denominator that we want. That's one of the views, the joys of the fundamental theorem of fundamental principle of fractions. Just as you can reduce, you can build up a fraction to be any denominator that you want it to have, within a reason, okay? Because of this fact, and it works backwards. Okay, so I can multiply a numerator and denominator by what? Well, what is this number as long as c isn't 0?
It's a whole number.
But what number specifically? Think about it. What's this number?
1.
So what's this number?
1.
So if you take 1 and you multiply it by something, what do you get? What you started with. That's why this principle works. So you can build up fractions by multiplying by 1. So let's say I have 3/4, and I want 3/4 to be written with a denominator of 16. I want the denominator to be 16. So what do I multiply 4 by to get 16?
Itself. 4.
Yeah. So if I multiply the denominator by 4, to keep the fraction equivalent, I have to multiply the numerator by 4. And in doing so, I end up at the fraction 12/16. Not reduced, but not what we were looking for. We wanted a fraction with a denominator of 16. So there's no need to reduce this. If it asks you, please give me a fraction with a denominator of 16, and that's the answer. What about 2/3? How about, 2/3. I want 2/3 with a denominator of 21. What am I going to multiply by?
Say that again, you broke out.
I want 2/3 with a denominator of 21.
Okay.
What am I going to multiply by?
By 7.
7. Like this?
7/7.
Oh, very good. 7/7. Okay, so we do that. 2 times 7 is 14, and 3 times 7 is 21. Okay. When we have fractions that are different denominators, we have to find what's called a common denominator. A common denominator, and then add them. That is the thing that most people just give up on math when they have to find common denominators. And it is not really that difficult. I don't think. Most people, it's just one. In fact, over the years that I've taught math, when people see this, for some reason, they get in their head that they could do this. And that is not true. Okay? So really what we're doing when we do this is we're taking... okay, yeah. Let me just make sure I'm on the screen here. Alright, we're taking 1/5, which is here. Alright, there's 1/5. And then we're going to take 3/4 and add them together. So what we have to do, and I drew it like this on purpose, with the lines this way on the bottom and the lines on this way on the top, because you can find the common denominator. What's the common denominator between 5 and 4?
20.
Right. 1, 2, 3, 4, 5 times 1, 2, 3, 4, 20. That's what you're doing. Yes, you can multiply the denominators and find a common denominator, but it's easier, and it's much easier to find the least common denominator, which is what people also struggle with. But common denominators work. It just means you're going to have more work to reduce with. So let's find the common denominator. We already did it. It's 20. So we're going to do this the loose fitting way, and then we're going to do it the harder way. The easier, the prime factorization way. I'm not going to call it the harder way, because it's not harder, but the more detailed way. Alright, so I want to make both of these denominators of 20. So I'm going to multiply this by 4/4. That gives me 20, right?
Yes.
And I'm going to multiply this by 5 over 5. Okay, and that's going to give me 4 plus 15, right? 1 times 4 is 4, and 3 times 5 is 15, and all that's going to be over 20.
19 over 20.
So the answer is 4 plus 15, which is 19 over 20. Now, where do we get 19 over 20 out of this? Out of this picture? Okay, this is 3 times 4, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this is 4 over 20, which is 1/5. So 16, 17, 18, 19. Because these are all going to be the same in the same grid. Okay?
Right.
Visualizing is not important. It is if you just kind of want to figure out what you're really doing. But when you see it, it makes these numbers kind of come together a little better.
Mm-hmm.
Okay, let's do another example.
Made it a little bit more complicated for me, but
Well, yeah, but
made it more confusing.
that's because you haven't done it for years and years and years. And if you've done it for as long as I have, then it wouldn't be so confusing.
Well, I understand how to get a common denominator, but it was the diagram that was throwing me off. Like, I'm not.
But how did we get the common denominator?
By multiplying.
We multiplied, and what did I do? I multiplied.
Well, I understand what you did. It
Okay.
just didn't make the most sense.
You understand what I did, but it didn't make sense. Okay, all right. I'm going to leave you alone. Okay, here we go. 3/4 minus 1/6. Now on this one, we're going to use what I like to call passing out candy method. And it involves prime factorizations. This is no fail. You will always have the correct answer if you do it this way. Okay? You can hear me?
Yep, I
Okay.
can hear you.
All right. So we're going to rewrite these, but we only need the prime factorizations of the denominator. And these are small, so they should be we should be able to do these in our head. So 4 is 2 times 2. And 6 is 2 times 3. Right?
Right.
Okay. I call it passing out candy, because when you have kids, they all want the same candy, right? If you have like 12 kids and you have, so many pieces of candy, they all want the same kind of candy. So what does this guy have that this guy doesn't want? What does this guy have that he doesn't have?
3.
It has a 3. So you give him a 3. And what does this guy have, this guy want that this guy has? He has 2 2s. So now they're the same. They have the same denominator. See how I did that?
Got it. Yep.
Now you can multiply. This is 9. 3 times 3 is 9. Plus 2 times, it's minus. Oops, minus 1. 2 times 1, right? So 3 times 3 is 9. And 2 times 1 is 2. And the bottom is 2 times 2 times 3, which is 12.
Oh.
Now we subtract 7 twelfths.
7.
We'll do a lot of these examples. You could either do that, or you could find the least common multiple, which is 12. Divide the number into this that makes this 12. That'd be multiplied by 3 over 3. And then do the same thing over here, or you could just do what I just did real quick. This way is a lot quicker if you practice it. Which I plan to do here. I'm going to load up some problems. Okay, let's do some more. 1/3 and 1/5. We're going to add these. It doesn't matter. Add or subtract. Oh yeah, subtract. We got to be careful because we're not doing negatives yet. So we'll be safe and add. Okay. What's special about these?
They both have common numerators.
The denominators are both prime. We're not even looking at the numerators. We need to find a common denominator. And they're both prime.
Okay.
So we don't have to find prime factorizations.
Nope.
This guy wants to be like him, so he wants a 3. But whatever I do to the bottom, I have to do to the top. And this guy wants a 5.
Right.
So now we get 5 plus 3 over 15, which is 8 over 15. Takes practice to do this. I know this isn't something. I don't do this when I teach. I mean, this is a review, but I don't teach this in like one day. It's like 3 days. Okay. Let's do one 3/4 plus 3/20. Now this one's a different because this is a multiple of this.
Right.
So in order to make 4/20, we want to make them the same. All you have to do is multiply this by 5. Okay? And then you get 15 plus 3 over 20, which is 18 over 20. Is that okay?
It is, but we can reduce it.
We can reduce it. I know because there's a 4 in the denominator. Here's an 8. It's 9 over 10. Okay. Let's do it the candy method way so you can see it in action.
Okay.
So it's 3/4 plus 3/20. So 4 is 2 times 2, and 25 is 2 times 2 times 5. What does he want to be like him?
5.
Oh, 5. And what do we do here? We multiply by 5. It's the same thing. But you can visualize it better that way. And then you just do what we did above. Let's see. Oh, these are okay. Let's do this one. 3 over 10 plus 2 over 15. Okay. This one is a good one. Okay. I don't know if we have to reduce yet. I haven't. We have to add them first.
Okay.
Okay. So make sure we can see over here. 10 is 2 times 5. And 15 is 3 times 5. Okay, so what does this guy want that this guy has? They want to be the same. Well, this guy wants a 3.
The other guy wants a 2.
And the other guy wants a 2. And now you have common factor. Everything's common. 2 times 5 times 3 is 30. And we have 9 plus 4.
Okay.
9 plus 4.
13.
Okay. And that is reduced because 13 is prime. And none of these are 13. So you already have it broken out for reducing too. It's kind of the other kind of nice thing there.
Okay.
All right. I'll just turn that over. It's not too bad. Most math people don't like to write on the back of paper, but paper's expensive. 7/10 minus 3/16. Okay, so in both of these, the numerator stays the same. Don't forget, subtract. Okay, 10 is
2 times 5.
2 times 5, and 16 is
2 times 2 times 2.
almost. That's 8.
4 2.
2 to the 4th, yeah. 4 2s. Okay, good. All right, so now we have to make these guys happy. So they want to be the same. He wants 4 2s, right?
Right.
He only has 1 2, so we're going to put 4 2s.
3 2s. You gotta do it to the top.
Yeah. Okay. You could cheat. You see how I cheated there?
I see what you did there.
This is pretty snappy. What's this guy want? He only wants one thing. 5.
He wants a 5.
All right. Now we have 56. 8 times 7 is 56. Minus 15. All over 2 times 2 times 2 times 2 times 5. 56 minus 15 is 41? Yeah, 41?
Yep.
Over 80. This is 2 times 5 is 10, right?
Yeah.
Times 8. 8. Is it reduced?
Yes.
Yes, because 41's not one of these. Because these are already broken out.
Right.
And 41 is?
It's prime.
Prime. Good. All right, a couple more. 7 over 30 minus 5. This one's going to be, might be gross. Over 24. Okay. All right. Okay, 30 is 5 times 6. Right? 30 is 5 times 6, and 6 is 2 times 3.
Right.
24 is 8 times 3. And 2 times 2 times 2. Okay. Alright. This is going to be a big least common divisor. The least common multiple is just 120. It's pretty big. But when you look at it with just the prime numbers, it's you don't even think about 120. Okay, here we go. Take a deep breath. They both have 3s, so neither one of them want 3s. Let's start with 2. He wants two more. He wants 3 2s. Right? So just give him 2 more 2s. And he wants and that's it. He don't want anything else. This guy wants a 5.
Right.
All right. Oh, look at this. This is going to be beautiful. All right. So then we have 28 minus 25 over 2 times 2 times 2 times 3 times 5. Right?
Mm-hmm.
And when we subtract those, what do we get?
3
over 2 times 2 times 2 times 3 times 5. So look, what's left? What's the numerator going to be? This is what the trickiest people.
40.
The numerator is
1.
1, and the denominator is. You had it right.
40, right?
40. Yeah. Okay. Good. All right. I'm hoping. Okay, these we don't have to borrow. When you borrow with mixed numbers, that's where you lose people. These aren't borrowing. We are not borrowing in these examples. Unless you want to see one where you have to borrow.
No, it's alright.
That might come up, but not today. Alright, when we subtract mixed numbers, and these are subtract, since I said borrow, you can line them up like this. Or you could make them improper fractions and subtract them. However you want to do them. I'd rather do this because it's smaller fractions. Okay, so over here, we're just going to deal... I didn't say borrow, so we could already subtract these. We know that we're not have to borrow, but I don't want to jump ahead. 4 is 2 times 2, and 3 is prime. Right?
Mm-hmm.
So they all want what each other has. He wants a 2 times 2, and he wants a 3. Right?
Yes.
Did I do that too fast?
No.
Okay. So we have 9 minus 4. Right?
Okay.
9 minus 4 is 5 over 12. 2 times 2 times 3 is 12.
Right.
And 3 minus 2 is 1. Don't forget this part. A lot of people do the hard part and then forget about the easy 3 minus 2. That's wrong. Why is it wrong? Because you didn't do this part. This part is part of the problem, too. One more, and then we're done with fractions. arithmetic. We got one more topic, and we're going to shoot it out.
Okay.
And it's going to be real easy, and then we're done. Okay, this one's easy because those are coprime again. Coprimes are easy. All right, so this is 1/2, and this is 2/3. To be alike, this guy wants a 3, and this guy wants a 2, right?
Right.
And 4 minus 3 is 1, right? 2 times 2 is 4. 3 times 1 is 3. 4 minus 3 is 1. And what's the denominator?
6.
6. Is that the answer?
No.
What's the answer? 3
2
minus
is
2
1.
is... There you go. Very good. Oh, I guess Sophie gets gold star.